We can describe the adaptive process for determining a congestion window through a state machine. So this state machine doesn't cover everything about a TCP connection, only that facet of a connection that is computing the congestion window. Our state machine is going to have three states: slow start, congestion avoidance, and fast recovery. I've drawn them in different colors just to have colors associated with each state. The congestion avoidance state is in bold here with a bold border to indicate that it's where we are most of the time in a steady state for TCP. We just described what happens with slow start though. Also, I haven't drawn all edges in this state machine yet. I've only drawn the edges that go from the three major states. As we saw, we go from slow start into congestion avoidance once our congestion window calculation reaches some threshold SS thresh. But while we're in this otherwise steady state, if we get a timeout, then we're going to go back into slow start. The third possibility is here because we have one more way of detecting and recovering from problems, and that is when we get duplicate acknowledgments. Like we described last time, if a receiver sends back 3 duplicate acknowledgments, then the sender side will treat that as an indication that packets are not getting through. They need to be resent, and we're going to try to do that more quickly than starting over with the slow start. So that's what fast recovery is about. When fast recovery does get a good ACK back, then it can go back to congestion avoidance mode after making some adjustments. Finally, it's possible for slow start to get those duplicate acknowledgments, and it'll also go to fast recovery in that point. And while we're trying to recover more quickly, we may just get a timeout, in which case we go back to slow mode. Filling in the missing edges now, this slow start mode, as we said, every time it gets a good acknowledgement back, it's going to increment the congestion window by MSS. And because that's a per packet acknowledgement, that's going to tend to double the control window if one setting fully succeeds. But if we get a timeout, then we're going to back off. We're going to start again, set the congestion window back to that lowest value, MSS, and also reduce or perhaps reduce our threshold to be half of whatever the congestion window was. I say perhaps reduce because it could be that this congestion window has gone well beyond threshold, as we'll see that happens in this blue congestion avoidance state, and so we may actually be upwardly revising SS thresh from what it used to be, but still reducing it to what we're currently trying as a congestion window. If we get duplicate ACKs, then the way we make adjustments is a similar sort of adjustment to the threshold. It seems that we have a congestion window too high, and so we reset our estimate of where it should be, the most it should be, to be half of the current congestion window. And then we also adapt the congestion window that we're working to be starting from that point, that new SS thresh, but then a little bit beyond that, 3 times MSS. Why is it 3 times MSS here? It's just that this is a good value that is probably somewhere in between SS thresh and where the CW end currently sits. When we move over to the steady state and we're in congestion avoidance, we don't leave the congestion window alone. Every time we do get a new acknowledgement back, we will bump the congestion window up because things seem to be working well, and maybe we should push towards an even higher value. We do that bump not by MSS, but MSS divided by the current congestion window. In other words, instead of every packet adding congestion window linearly, which leads to an exponential increase in the size of CWinds like we have intentionally in slow start, we make it go up by much less. This ends up being a kind of linear increment on the congestion window. And then when congestion avoidance has to go into fast recovery, we do the same sort of thing of adjusting our threshold and congestion window. The reason these are grayed out is just because they're the same as the non-grayed out versions, so just showing you the copies of the code. When we're in fast recovery and it does work out, we get a good acknowledgement. Then we go back to congestion avoidance and set CWind to SS thresh because we seem to have established a new good threshold. So these edges are all in place and show all of the actions in terms of adjusting C, the congestion window, and SS thresh. To show all the packets that we need to send, then we can add in more detail here. So every time we get an acknowledgement in the slow start mode, not only do we increment the congestion window, we also send new data out to see if it gets there. And when we get timeouts, that's when we need to resend missing, and so on. Our edge here was when dupax is 3, so every time we get a single duplicate ACK, we need to increment our dubacks message. Every time we get to timeout, well, that's when our dubacks goes back to 0 because we're going into slow start mode and giving up on the fast way of counting duplicate acts. Congestion avoidance normal mode, again, we send new data every time we get a good acknowledgement, and also here, if we get a duplicate X, we're going to bump up doX. So this is the complete picture for all of the packets that we send, acknowledgements that we receive, or duplicate acknowledgements that we receive, and how the congestion window and SS thresh adjusts based on those actions.